First of all, let's all give this space a round of applause. I'm really excited that this is our second event in Club 21. The amount of work that it takes to turn this nightclub into a place where you guys can hear us talk about nerdy subjects is probably a lot, so I'd really like to thank our hosts. We have a really fantastic night for you. I'd just like to say that slugs are weird. No offense to UC Santa Cruz alumni. We're talking about weird. Slugs are weird. Like Futurama weird. So this particular slug is a member of the Elysia species. You'll notice it's green. It looks like a leaf. It doesn't look like a slug. In fact, other scientists put it in things like plant physiology or molecular plant. Right? So they're like slug, plant, plant. So this slug actually eats algae, and it absorbs the chloroplasts of the algae. It actually has horizontal gene transfer, so it's able to efficiently store energy from the sun. So photosynthetic slugs, great. But that's not even that's the tip of how weird slugs are. Does anyone know what this is? Yeah, so I heard it. So this is not a slug. So this is man of war jellyfish, known for doing things like this to people. Don't go swimming, obey the signs. So there's, Latin makes everything kind of sexy, but that's, blue sea slug. Looks like that. Beautiful, beautiful creature. These motherfuckers eat man of war jellyfish, absorb the poisonous spines, and therefore themselves become poisonous and will sting you with the spines that they just ate. Slugs are weird. And now to tell us a little bit more about how slugs are weird, here's Vanessa.
Which can be a little bit awkward when I go to parties, because people are like, oh, what do you do? And I'm like, well, I look at slug genitalia. Which really can be a little bit awkward, depending on what kind of party you're at, because sometimes people think that's really cool. So hopefully that's the kind of, vibe we have here tonight. So the title of my talk tonight is Sex, Slugs, and Rock and Roll, which made me a little bit anxious, because I was like, oh, that's such a badass title, and I don't know if I can live up to that. So that's pretty much what I'm going to be talking about tonight. And let's see here. So first we're going to do a little bit of a remix, and we're actually going to start talking about slugs. And we'll leave the sex for later on in the talk. Alright, so one of the things about slugs is you probably on a daily basis don't think about them too often, particularly sea slugs, which are the type of slugs that I study. Good looking, right? It's a beautiful slug. And this one is typically found further south, but lately it's been popping up in places even north of here. And one of my colleagues is actually looking at this question, where are they coming from? So that should be interesting. Look out for that. More recently, there's been news of these giant purple blobs. So this is a horrible picture because this is on land, and in real life they look a bit better than that. So this is called a sea hare. It's a type of sea slug that looks a bit like a rabbit, sort of, as much as a nipper can. And unfortunately, when they're on land, they just look kind of sad like this. But they've been popping up locally recently as well. More recently in the news, my colleagues at the California Academy of Sciences just got back from the Philippines, where they discovered about 100 new species of marine creatures, and about roughly 40 of those were new species of sea slug. So that's pretty exciting. And okay, Tell me, raise your hand, who has gotten emails or Facebook posts with this image before? Anyone? 2 of you, that's it? 3, 4, okay. Yeah, cheer if you've gotten this viral email. Yeah. Okay, I get this all the time. And I absolutely love this sea slug. It's a really cool looking sea slug. It looks a little bit about like some anime character or something, Pikachu-ish. But this thing goes around, it gets viral every like maybe twice a year. And people are really excited because they're like, what is that cool thing? Well, this is a sea slug. Rick actually showed you a better picture of it in the water before. And we'll talk a little bit about some of the relatives of this particular slug in a bit. Okay, so before we talk a little bit more about sea slugs specifically, I need to point out these imposters because I frequently have people asking me about things that look kind of like slugs. They have a slug-like shape to them, but they're not actually sea slugs like what I studied. The first one of those are sea cucumbers. Raise your hand if you've ever held a sea cucumber before. Wow, a lot of you have. That's awesome. Okay, so sea cucumbers are not at all closely related to the animals that I study, sea slugs. They're actually more closely related to us. They are a type of echinoderm. So they're related to things like starfish, sea stars, sea urchins, crinoids, sea lilies, those types of things. And some of them can look quite deceivingly like a sea slug, especially this one. Recently on Facebook, there are a lot of Nudibranch Facebook groups, so if you want to join, you can look for that. Someone posted a picture with a bunch of these, and someone had to tell them that they actually had some sea cucumbers in there. They got to go to another group, go to the echinoderm group. These, usually though, you can tell apart because they'll have 2 feet. So if you look on the bottom, like a sea star, they've got 2 feet. And usually they're a lot larger than most of the slugs you'll encounter. Now on the right, this imposter can be really tricky. This is a type, it looks like a nudibranch, doesn't it? Or a sea slug, right? It's brightly colored. If you look carefully, it's got these 2 little parts here that kind of look like the sensory organs on the front of a sea slug. But this is actually not at all closely related. This is a type of flatworm, a polyclad flatworm. And these can often be really good mimics of nudibranchs in particular. So a lot of these I think are also toxic. A lot of nudibranchs are toxic, so there may be some mimicry going on there. Pretty cool though, but you gotta watch out for those. Easily misidentified. Alright, so first we gotta talk about what exactly these sea slugs are. And if you remember, or think back to your high school class or your biology class and when you went to college or high school, whatever, they are first and foremost a type of mollusk. So mollusks, bonus points for anyone who can name the 7 extant classes of mollusks. Anyone want to give that a try? Anyone? I know you know. I know some of you know. Some of you laughing right here. No? Okay. Fine. These are mollusks here. So it includes things like gastropods, which includes sea slugs. You have things like this. This is a bivalve, a clam. But it also looks like a monococophora, this drawing here. So monococophora is another group. But you have things like cephalopods too, some other really cool mollusks. Alright, so the nudibranchs are a type of gastropods, snails and slugs. And this is a really gross simplification, but typically when I'm talking about sea slugs, I'm talking about a group that includes the nudibranchs. So it actually includes a lot of other groups of slug-like mollusks that live in the ocean, but not all of those are nudibranchs. So the way you can think of it is that all nudibranchs are a type of sea slug, but not all sea slugs are a type of nudibranch, okay? But this diagram here is not a very good representation of their relationships. And their evolutionary relationships are really important to me, because that's what I study. Alright, but some of these other groups of sea slugs can be a little bit misleading, and we often see them misidentified as nudibranchs on the interwebs. But a lot of them are really brightly colored like their nudibranch relatives. So you've got, these are some non-nudibranchs here. And what's cool about these sea slugs is a lot of these different groups actually still retain shells, but they're often reduced or they're internalized. And so this is a really interesting model to study the loss of shell evolution, which is one of the questions I'm interested in. And a lot of these are really beautiful. All right, so the name Nudibranch literally means naked gill. And the reason they're called naked gills is if you think about these animals, they're snails, but you'll notice they're missing something really obvious. What are they missing? Yeah, they're missing their shell. So whereas some of those other groups of sea slugs may have a shell that's reduced or internalized, one thing that all nudibranchs have in common is they have no shell in their adult stage. And this is some of the diversity you see within the nudibranchs. So you have different groups within the nudibranchs. Some of the ones you're most likely to see are likely these types right here, with all of these structures that kind of poke out the sides of their bodies or the backs of their bodies. This type is called an eyelid nudibranch. And the one that Rick showed earlier, the like anime-looking Pikachu-ish thing, that's a type of eyelid. And this other one over here is a type called the Dora nudibranch. And this is, for me, since I study Dora, it's a pretty typical nudibranch. And so you can usually find a nice little tuft of gills located on the back. That's what this is right here. And then you'll see these two little structures at the head end, and those are called the rhinophores. So they use that to sense different things in their environment. All right, this is one of my favorite species, actually. This is Gymnodoris willeni. It's hard to tell from here, but they've got these really cool speckly gills and rhinophores. All right, and then this one here, this is actually a type of nudibranch called a dendronodid. And the only reason that I included this here is because to me this looks like a crumpled wad of used dental floss. And this is actually what this animal looks like in real life. This is actually recently described by my advisors from my master's. So that's a really crazy looking nudibranch. All right, but an interesting question is, you know, if you're a gastropod and you have a shell, you know, what do you use that shell for? That's right, everyone knows it. It's like the first thing you learn about animals when you're a kid, right? It's like shells are used for protection. That's what snails have them for. So if, you know, if the shell is such an effective way of, you know, reducing predation, why would you get rid of your shell? Well, you better have a pretty good other way to defend yourself, right? So we're just going to talk a little bit about nudibranch cuisine, because it turns out that a lot of these defense mechanisms come from the food that these animals are eating. So if you look here, you'll see a little menu for nudibranchs in general. So they eat a lot of animals. In fact, that's one of the things I forgot to mention is that all nudibranchs eat other animals. They're carnivores. But they eat animals that a lot of people don't really consider to be animals. Well, too bad for you, because they are. But they're animals that don't really move around a lot. So things like rhizoans, corals, hydroids, these are related to jellyfish, so they can sting, so can corals. Things like sponges, and then this thing here called an ascidian or a sea squirt. So they eat things like that, and then the ones I study actually happen to eat other nudibranchs, which is pretty badass. All right. So what these nudibranchs are able to do in many cases is they will take the defenses of the food that they eat. I mean, think about it. If you're eating, I've been stung by a hydroid before. It was not pleasant. It hurt for more than a month. Okay? But what some nudibranchs can do is they'll eat hydroids and relatives of hydroids. And what happens is they're not really deterred by those stinging cells. In fact, what happens is as the stinging cells pass through their digestive system, which there's this little schematic over here, it actually passes through and gets diverted up into the serrata here to the very tips where you have a little storage area called a nitosac. And what these eyelids can do is they'll actually store those stinging cells in there and use them as a defense mechanism against predators that might try to eat them. So it's kind of like they're stealing superpowers from their food. It's pretty awesome. Okay, other nudibranchs, including this lovely nudibranch right here. This is one of the best nudibranchs. I heard that, Josh. This one I'm fond of because it's a Gymnodoris, that's what I study. They're not the most aesthetically pleasing, but they're badass, so it's okay. So these ones actually have these structures underneath the skin that are presumably able to secrete acid or some sort of defensive compound that they're getting from the food that they eat. And remember, my badass nudibranchs eat other nudibranchs, so those defenses don't work so well on them, which makes them, again, extra badass. Okay, some other nudibranchs, they don't necessarily have really obvious glands in their skin, but they're able to secrete a lot of noxious chemicals to deter predators. And so I put a picture of this one because it's particularly gross, actually. If you go scuba diving on a reef, you'll find relatives of this one everywhere because no one wants to eat it. It's disgusting. And if you're a scientist and you happen to collect it and you touch it with your hands, you're going to smell those toxins on your fingers because it's so strong. And you can't even keep this in a tank or a container with any other nudibranchs or anything else for that matter because it'll actually kill all the rest of them just by being in the same enclosed container. It's pretty wild. So pretty effective defense mechanisms, and that's how you ditch a shell, evolutionarily speaking. All right, so now for the juicy stuff, and away from the slimy stuff, except it's still slimy. All right, so we're going to talk a little bit about slug sex because it's just like pretty different from what we're accustomed to. All right, and I do have a disclaimer. I don't actually study, sexual behavior in nudibranchs. Most of the slugs I study are dead, so we're a little bit past being able to observe that. But I feel like I qualify to talk about sex in slugs because I've spent a large proportion of my time looking at the sex organs and genitalia of these creatures. So that's mostly what I'm going to talk about here. So if we think about slug sex, the first thing that's pretty interesting is that nudibranchs are all hermaphrodites. So they are both male and female. They've got all the goods. And sometimes, they're usually simultaneous hermaphrodites. So they will, when they're engaging in a sex act, they can be both the donor and the recipient in that sex act. This here is actually a photo of the process of this copulation between these two species of Nymphrorotha here. Another interesting thing about nudibranchs is a lot of them, if not all, I haven't looked at the penises of all nudibranchs, so I don't know for sure. But firsthand, I know the ones that I study, their penises are actually covered in spines. That doesn't sound very pleasant if you're a female slug, but they all are, so, I guess they put up with it. So, basically this is actually the penis of one of the slugs that I study. This is actually one of the species that I'm currently describing and naming. That's exciting. And this little insect here are the spines that cover the surface of this penis. You might wonder, okay, what's up with you guys looking at, slug genitalia so much? It's a little weird. This is pretty typical when you're a taxonomist, because actually a lot of the times you'll notice differences between species in the arrangement of the sex organs and whatnot. And sometimes things like these spines can actually be informative and can tell you how things are related to each other, or if you're looking at two different species. So it's pretty important. All right, let's see here. Oh, genital opening. Yeah. So the thing about these hermaphrodites too is that their genital openings are all on the right side. So you can actually see that. So if you look at them, whenever they're about to mate, they'll actually line up with their right sides sort of next to each other, and that's how they do the D. Don't worry, we've got some video. Okay, so this here, it wouldn't be about the video, right? Okay, so these are two Gymnodoris nudibranchs, again, the badass slugs that I study. And this is just a short clip that actually shows you them mating. And this is really cool because if you look carefully, you can actually see the sperm being transferred there, which is pretty wild. So this is going to come up again, and I'll actually show you. So look carefully. These are the genitalia hooked together. And this is actually really interesting because, so they both have a penis and a vagina. Yeah. Oh, there's the sperm right there. You guys see that? That's crazy. It's pretty cool. Okay. Sorry. Alright, I've only got a limited amount of time to show you guys these things. So this was kind of a weird study that came out a few years ago. This species here is relatively common in Indo-Pacific reef areas. This is Gymnodoris reticulatus. It's a nice red nudibranch. There's a study that came out a couple years ago that basically showed that they have a disposable penis, right? There's like a song, yeah, right? Here's where some of the rock and roll comes in. Okay, so they actually, after mating, whoops, that's a sneak preview. After mating, they will actually dispose of their penis. It's spine covered, okay? They dispose of it. That's what you see here. And this, it's a little blurry here, but this is their penis covered in spines. And interestingly enough, the authors, speculated, well, why would they dispose of their penis? That's kind of a weird thing to do. And what they speculate is that since the penis is covered in spines, they actually might use it to remove sperm from competing males that have copulated before them. So this last figure here, all this like stuff here, that's actually the sperm, and it's kind of tangled up in the spines. So maybe it's a way to remove competing sperm. All right, really quick, because I'm running out of time here. This is really cool. So back to the Gymnodoris, they're awesome. And I told you that they eat other Nudibranchs too. Well, sometimes they'll actually eat each other while they're doing it. So this series of photos here actually shows two of the same species. They're different colors. They're all entangled in the act here. And then this white one just decides he wants to eat the orange one. So you can see here, they're actually still mating. They're still hooked up here as this white one here is eating the orange guy. And in the end, just like a strand of spaghetti, this Gymnodoris here just kind of slurps up the rest of its partner. It's a little bizarre. Alright. So, after all this sex happens, they lay eggs. That's what you see here. They're usually laid in ribbons like this. Am I on time? I hate asking that in the middle of my presentation. Let's see where. Okay, we're going to keep going. Typically, many species will hatch into a larval stage that floats around in the plankton for a while until it's ready to settle. And then it'll grow into an adult nudibranch like this. But some species are actually really cool and they bypass this larval stage and they'll actually hatch into a juvenile slug directly, which is pretty cool. Alright, finally the rock and roll. Okay, so when I was growing up in high school, I wanted to study biology and I wanted to study something to do with the music business because let's face it, I just wanted to be a rock star. Like, who didn't, right? I didn't realize that I would get to do both because it turns out research is a little bit like rock and roll. So one of the things we do, and I really want to emphasize this here, because lately on the Facebook groups there's been a lot of people kind of bitching about scientists that collect specimens. So I just wanted to address that because a lot of the times we need dead specimens to be able to study them. I can't dissect a live slug, stitch it back up, send it on its way back in the ocean, okay? But I promise you, the type of collecting that we do is not very destructive to the environment. Far less destructive than seafood harvesting is, so just FYI. So that's important. So we do a lot of collecting, and one of the techniques, and I give props to one of my colleagues, we literally call rock and roll, because a lot of these slugs are found on the bottom sides of things like coral rubble, like you see here, and on the bottom of boulders like this in the intertidal or while you're scuba diving. This is actually the most badass picture of myself that I own, so I had to put that in here, even though this is just me on vacation in Puerto Rico. One of the photos. So I just put that in there, because it's pretty cool. But so that's one of the ways we collect these slugs is on scuba, and sometimes just through the intertidal. Alright, so one of the things that I do is I use DNA to establish relationships. So this is really important because this is how we can actually study how different traits evolved in slugs or any other animal. And traditionally we would use this using morphology, so studying the shapes of different body parts and the anatomy. And we still do that, it's actually really important. But DNA has kind of revolutionized the way we determine these relationships. And in the end, you get trees like this that helps us to understand these relationships. Again, how am I on time? Good? No, I'm going to keep going. All right. So again, this is the genus that I study here, Gymnodoris. A lot of them eat each other, other species. But a lot of them are really confusing because they look the same. A lot of them have this shared pattern of translucent white with orange spots. It gets a little annoying because they become really difficult to identify. And people are so obsessed with nudibranchs and sea slugs that there's many websites, including this one called Nudipixel. Yeah, it sounds like a porn site, but it's actually a site devoted to nudibranchs. And what people do on Nudipixel is they'll actually upload photos of slugs that they find while diving or, poking around in the intertidal. And then a panel of experts will identify them for them. So what I did is I went onto this site and I looked at one species of Gymnodoris, and I counted up how many species I identified as separate species that had been identified by the panel of experts as one species. And it turns out that I counted, people had posted 16 different species thinking it was Gymnodoris alba. And the panel verified the identity of 6 different species as Gymnodoris alba. So clearly people aren't very good at identifying these guys. Are we any better? This is hard to see, so I apologize. But this is some of my results from my research. And what this shows is some of these translucent white with orange spots that we thought were the same species, it turns out they're not even that closely related to each other. There's like one cluster here, 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 and one here. So it turns out that DNA is actually really helpful for us to kind of figure out how they're related to each other and actually what an actual species is. And I'm getting better at identifying these, some sort of like connection I have with them. Again, how am I on time? So good. Alright, keep going. Okay, so this is my last story. Basically, a few years ago, we went to the Philippines on this huge expedition. We went diving at this one dive site, 2-night dives over a couple of days. And we collected all of these Gymnodoris slugs here. And we thought, okay, maybe these belong to 2 or 3 species. They look very similar, don't they? They're all translucent white with orange spots. Imagine that. Well, it turns out that what we found is those species, or those individuals, actually represented at least 7 different species in this genus just living under this one dock. That's mind-blowing, because there are a whole bunch of other, genera living under this dock as well. So it turns out a huge percentage of nudibranchs are actually still undescribed and unknown to science. And just in the genus that I studied alone, about 80% of the slugs that I studied had no name. We didn't even know they existed before. It's pretty mind-boggling how little we actually know about our planet. Alright, so what you should take away from this is, even though you might not think much of slugs in general, they're actually pretty important, and they can be useful for helping us as indicators of our environment, sort of what's going on. Because remember, a lot of these slugs, they're not typically found in summer. So we think, maybe warmer waters might be to blame, or maybe you have, an unusual weather event, El Nino or whatnot, contributing to that. So that's more of the slugs that don't have shells or not. This is something that I kind of floated through my head at one point. And the thing was more in the context of, if they don't have shells, are they going to be less impacted by ocean acidification? The thing is that, remember, some of them pass through that larval stage. The larval stage does have a shell, so they would be vulnerable to ocean acidification in that state. But either way, we don't have enough data to even answer that question. With roughly 80% of the species just in the group that I studied, we didn't even know existed. It would be really difficult. The reason we know about the ones moving north on this coast is a lot of people have been, monitoring different sites over the span of decades, and so they have really good data to show that, these species weren't present here previously, and so they can really show that there's been a northward migration. And because of that, if you guys are interested in this stuff, go get out there, record your data, because citizen scientists, you're actually really helpful to answer these kinds of questions. It's important data. I'm going to avoid you.
What sort of explanation is there for convergence that site a little translucent before spot?
So I don't think it's convergent. The question is, how do you explain the convergence of a similar color pattern? Is that right? So in the case of the ones I studied, translucent white with orange spots. Great question. I don't think it's so much convergence. I think they have a common ancestor that had that common or that pattern, and then there's just no selective pressure on the color pattern for those guys. And so you just get the same color pattern, and they speciate, based on other pressures. Yeah. There are lots of medical uses for sea slugs. So a lot of those compounds that I mentioned before are actively being researched for potential drugs for different diseases, cancer, HIV, things like that. And there are, I believe, certain drugs that are already in the testing phases. 2 more questions. Okay. Who really wants to answer their question, or want an answer to their question? Okay, you in the gray shirt. Great question. So the question is, they feed on a lot of different prey items that have, different defenses, like chemicals and whatnot. Do certain nudibranchs specialize on a certain prey item, or are they generalists? And in general, they tend to specialize. You might have like a sea slug that'll feed on several species of hydroid, or several species of sea squirts, basidians. But you don't typically see a nudibranch that's going to be feeding on hydroids and sea squirts and other nudibranchs. There are some exceptions to that. I can think of a local species, Fidiana, that actually feeds on other sea slugs and hydroids as well. So in general, they specialize. That's one of the questions I'm interested in with Gymnodoris is, do you have certain species that feed on many different types of slugs, or specialize on either one species or genus or family of prey item? Great question. And one of them actually feeds on the fins of goby fishes, which is really wild. I just had to throw that in there. Yes? Yes, I only heard part of the question, but I heard the word color. I didn't talk a lot about the color. Yes, a lot of the color is thought to be used either as enigmatic coloration, so a warning signal to predators, don't eat me because it might kill you or make you sick. And in some cases, that may be true, but there needs to be more work done. So there's some people that study that specifically, and they will extract some of the toxins from nudibranchs, add it to pellets, and try to do experiments feeding it to different potential predators of nudibranchs. And so they can actually test, are these color patterns that are associated with a particular type of toxin, effective in deterring sea stars, or which can't see the colors anyway, so that's a horrible example, but you know what I mean. All right, thank you.
So thanks to Vanessa. Vanessa's going to be right up here for the next 10 minutes to answer any of your questions. I'd encourage you to partake in the bar. Go say hi to the Oakland Public Library. If you do not already have an Oakland Library card, you should go get one. You should also frequent our food vendors, the Lumpia Company and Shades of Sugar. We'll be back in 10.
We want to make a quick announcement. At the bar, we have $2 shots of Southern Comfort and $3 Southern Comfort and Cokes for the next 10 minutes.
It's like about dying as the dinosaurs possibly did. Because there's so many other ways the apocalypse might happen. So don't even worry about asteroids. What about supervolcanoes? How many of you are familiar with the supervolcano? Show of hands. Okay, a few of you? Right. Supervolcano is kind of like a regular volcano, but super. They're really huge. And the initial blast of a supervolcano, which apparently there are a few around the world, the initial blast could cover an area as big as the size of North America. But don't worry too much about the initial blast, because even if you should survive that, all the volcanic ash and dust that would be put up into the air would block out the sun and create global cooling, and no more crops would grow, and we'd all die of starvation. So that's fun. Okay. Oh, I forgot to tell you this. There's one under Yellowstone. Just in case you thought you wouldn't be close enough to be seriously affected. The one under Yellowstone, it erupts about every 600,000 years, and the last time it erupted was 620,000 years ago. So we're due. Alright, but that's not the only way we might die. There's also a pandemic. This is the Spanish flu, that's a little fuzzy, which many of you have heard of, especially if you watch Downton Abbey. The Spanish flu was sort of like the mother of all pandemics, or all bird flus anyway. It was the H1N1 virus, and apparently almost all bird flus today are descendants of this virus. In fact, for example, in the late 50s, there was an outbreak of H2N2 influenza, avian influenza, which killed 1.5 million people worldwide, and has been more or less eradicated, but still exists in wild and domestic birds. And also, people born after 1963 have no immunity to it. So, that could happen. And you know, we all live in an urban space where this stuff gets transmitted super fast, and there's global travel. It's going to be great. So don't worry too much about asteroids. The pandemic is coming. Then there's always the hope for robot ascension. I think this is my favorite one of all the disaster scenarios. These are just a few of our robot friends and weapons that we have currently. So we're rapidly approaching what some people would call the singularity, which is that moment when robots become more intelligent than humans. In fact, the UN, just in April, had I have to get this right, a convention on conventional weapons where they discussed the question related to emerging technologies in the area of lethal autonomous weapons systems. Yeah, lethal autonomous weapons systems. Because we got to differentiate between your standard drone killing robot killer, that is, no, killer robot, thank you. Your standard killer robot that's controlled by a human versus your autonomous killer robot that's making decisions for itself and will inevitably choose to wipe us out, because come on. So that's only a matter of time. And then lastly, we have germline modification, another great one. Germline modification, yeah, I wish I could credit who, yay Google, I don't know who made this wonderful graphic. But this is basically changing the genes in eggs and sperm and embryos so that the genetic change that you create gets passed on to the next generation, as opposed to like gene therapy, which can help treat or cure disease, but only affects that one patient and isn't passed on to the next generation. These are changes that enter the germline. This already exists. For example, you might remember from the news a few years ago, the procedure where infertile women with genetic defects in their mitochondria were able to reproduce using the donated egg of another woman, and the offspring had DNA from both the egg donor and the mother and the father. So, very interesting, right? And there's like a whole line of thought called transhumanism, which I learned about today, which is, people who really want to bring forward this more human than a human, better human being through technology and genetic modification. And some people are uneasy about this and feel like once we improve humans significantly to the point where they're not actually human anymore, there will probably be an inevitable war. So let's talk about that for a second. You all have to pick a side, all right? There's going to be 4 camps. I've been researching this, and this is what I've discovered. Whatever the apocalyptic event may be, genetic war, maybe asteroid, maybe supervolcano, there will be survivors, and we're going to be in 4 camps. First, you're going to have the machines. You could be part of this. You could upload your consciousness, get a robot body, a positronic brain, if you will. I felt that image was more appealing to recruitment. There's going to be the cyborgs, the enhanced humans with tech, but still largely human. We need a better recruitment picture here. Then there's going to be your genetically modified human. Let's call them the mammals. And then you're going to have your regular old humans. You know, it's pure. It's pure. So start considering, because it's coming, and you're going to have to pick a side. In the meantime, to talk about one apocalyptic scenario, which would be asteroids, we have Gerald McKeegan.
Okay, well, now that Rebecca has scared the bejeebers out of you, I'm going to calm it down a little bit. A room full of nerds, and I know that as nerds you all watch the Science Channel, the Discovery Channel, the History Channel, and all those other highly reliable sources of accurate scientific information, right? So if you have, you've probably seen pictures like this. Swarms of asteroids orbiting around the sun, so many of them and so close together that if you were a starship commander, you'd have a tough time getting through them. If you go to a website, like a NASA website, you might see a diagram like this. It's got lots of pictures or lots of little dots showing where all of the known asteroids are. And again, there's millions of them out there. So you might wonder, how do we get through an asteroid field? Well, video games, computer games, movies, they all show you how to do it, right? They show the spacecraft trying to fly their way through an asteroid field. And of course, you remember in Star Wars, Han Solo was trying to fly the Millennium Falcon and he's dodging and driving and everything. And C-3PO says, "Sir, the odds against successfully navigating the asteroid belt are about 3,720 to 1. So this is the impression everybody has of asteroids. Millions of them out there flying around in swarms, and we can't get through them very well unless we really navigate the spaceship the right way. The problem with it is it's simply not true. It's bunk. This is what an asteroid field really looks like. Oh my God, it's full of stars. This is an actual picture of a field where asteroids exist. And this is what they look like. Space is a really huge place. And you can have millions of asteroids out there, and they'd be hundreds of thousands of miles apart. And that's exactly how they are. Now there is an asteroid in this image. If you look carefully, everybody's found it already, right? Okay, if you look carefully, right up there, there's an asteroid inside the box. You see it? Okay, I'll help you out here a little bit. There's our asteroid right there. Now, granted that they are far apart, but if you are flying around, flying through an asteroid field, eventually you will encounter asteroids. And that's exactly the situation with the Earth. The Earth is flying through an asteroid field. This gives you an idea of a 5-month period with the Earth's orbit, and it shows you all the asteroids that it encountered during that 5-month period. Each of those little dots represents an asteroid, and you can see that we're flying through a shooting gallery. Now, they look close, but actually they're pretty far away. Most of the asteroids that you see are at least 500,000 miles away from the Earth, and some of them are more than 1 million miles away. But we do consider them to be near-Earth asteroids. But some of them get a lot closer. Sometimes asteroids get actually closer to the moon. In fact, about 30 times a year, asteroids get closer to the Earth than the moon. So we don't hear about it because they miss us. Occasionally we talk about it when we get really close, but most of the time we just see them go by and no problem. But the evidence of asteroid impacts is very clear when you look at the moon. Even if you look through binoculars, you'll see that the moon is covered with craters, and it's a record of billions of years of asteroid and comet impacts. In fact, if you look at the moon through a telescope, you'll see just craters on top of craters on top of craters. The moon has no atmosphere, it has no weather, no plate tectonics or anything like that. So impact craters just stay where they are and don't erode. So we see craters that are more than 1 billion years old on the moon. So you look at that and you say, well, okay, there's a lot of craters on the moon. Obviously the moon's been hit by a lot of asteroids, but what about the Earth? There aren't a lot of craters on the Earth. The fact is, the Earth, for every impact on the moon, the Earth gets hit 16 or more times. The Earth is bigger than the moon. It has stronger gravity than the moon. So that means it gets hit a lot more often. So where are all those craters? Well, remember that the Earth has weather, we have plate tectonics, we have oceans, we have bulldozers. So there's lots of stuff to kind of get rid of the craters. Nevertheless, we do have quite a few craters on the Earth. We know of at least 180 craters in Australia. It's about 350,000 years old. This one, very interesting crater. This is Beringer Meteor Crater. It's in Arizona, about 30 miles outside of Flagstaff. And if you are a true nerd, you must go there. This thing is fantastic. It's 3/4 of a mile in diameter. It's 650 feet deep, and it has a visitor center. So you can go there and actually contemplate what it would be like to have something like this happen. The asteroid that caused this hit the Earth 50,000 years ago. It was about 40 meters across, and by our current definition of asteroids, we consider that a small asteroid. Nevertheless, if you were within 5 miles of this crater when the impact occurred, you'd be hit by supersonic rocks flying out of the crater. We have actually detected evidence of shockwave damage 100 miles away from the crater. So this is a pretty spectacular event. A few more recent events. In 2010, a couple of Italian scientists were browsing through Google Earth, and they were looking at the deserts of Egypt. And they noticed a round circular feature, and they said, gee, that looks like an impact crater. So they went there, and sure enough, there was a 150-foot diameter impact crater that we figured is somewhere between 3,000 and 5,000 years old. There was ejecta thrown out of the crater more than 500 feet away from it. So again, very small object hitting the Earth makes a very big crater. In June of 1908, a small asteroid, again about 40 meters across, came down over the Tunguska region of Siberia. and it did not make it all the way to the ground. It exploded before it hit the ground at about 30,000 feet. That explosion leveled 200 square miles of dense forest. Fortunately, it was a very remote area. There weren't any people around, so nobody was hurt. But it flattened all the trees, and the few that were still standing, all the branches were blown off of it. And it took more than 10 years before they were able to actually identify what it was that had happened here. More recently, 2007, an asteroid came down in Peru. And this was a very small asteroid. It was only about 6 feet across. It hit the ground out in a pasture near Caracas, Peru, and punched a hole that was about 45 feet in diameter. Blew out a couple of windows in the little village that was nearby. Didn't hurt anybody. However, this flat pasture area was actually the floodplain for Lake Titicaca. And the water table is only about 6 or 7 feet below the ground level. So very quickly, the crater filled up with water. And of course, you all remember this event, right? 2013, Chelyabinsk, Russia. An asteroid about 17 meters across came down, exploded in the sky, and blew out windows, knocked down walls, and injured nearly 2,000 people. Interestingly, the explosion of this asteroid did not happen over Chelyabinsk. It was actually about 30 miles away from Chelyabinsk. So that gives you an idea of how much energy was involved here. Another interesting story, Chelyabinsk is where the Russians keep their nuclear weapons that aren't being used. So when this event first happened, all the Russians assumed that those Amerikanskis were attacking us. Okay, I want to get a couple of terms defined here real fast, and we use the term NEO quite a bit. A NEO is a near-Earth object. It's an object that comes within 44.7 million kilometers of the sun, or of the Earth, rather. Now, that number is kind of an odd number, but it actually refers to the distance to Venus. We don't want to call Venus a near-Earth object, so we made it a little less than that. Another term that we use quite often is PHA, potentially hazardous asteroid. It's a subset of the potentially hazardous objects. A potentially hazardous asteroid is an asteroid that's at least 150 or 140 meters across, and it comes within about 7.4 million kilometers of the Earth. These are the asteroids that we consider to be dangerous. Now, they say 7.4 million kilometers of the Earth. I should correct that. It's actually 7.4 million kilometers away from the Earth's orbit. You can pass right across the Earth's orbit if the Earth's on high. About 1993, scientists knew about impacts, but they didn't really think they were much of an issue, and it wasn't getting a whole lot of attention. But a few astronomers thought this was something we needed to worry about. So 3 astronomers, Gene Shoemaker, Carolyn Shoemaker, and David Levy, got together at Mount Palomar Observatory and started scanning the skies looking for near-Earth objects, potential impactors. After a while, they spotted this guy right here. This was actually a comet that was orbiting around Jupiter in a highly elliptical orbit, and Jupiter's strong gravity had broken it apart. Now there were about 20 pieces all strung out in what they call a string of pearls. They looked at the data and they said, hey, this is going to hit Jupiter next year, 1994. So they announced this to the world, and scientists all over the world started paying attention. And they pointed telescopes at Jupiter and wanted to see what would happen. Expectations were low. The largest of these fragments was only about 1 or 2 kilometers across. Jupiter is 140,000 kilometers. So this is like a grain of sand hitting a beach ball. So they didn't have high hopes, but they thought maybe they'd be able to detect something if enough telescopes were pointed at Jupiter. What they saw was way more than anything they would have dreamed of. Each of these impacts produced an impact point that is larger than the Earth. Jupiter is surrounded with clouds. Those clouds absorbed the impactor and created a shock wave that spread out to an area larger than the Earth. So they realized there's a whole lot more energy involved in these impacts than they realized. That got everybody's attention, and especially you got these guys' attention. Oops, these guys, there we go. Got their attention, which is always a bad thing, right? So later on in 1994, a House of Representative committee gave direction to the District of Columbia. So that got a little more attention. So in 2005, Congress passed the George E. Brown Jr. NEO Survey Act. And this directed NASA to find 90% of all near-Earth objects larger than 140 meters. And they said to do that by the year 2020. So that was in 2005, or 10 years into that. Let's see how we did. Well, finding the 1 kilometer or larger, mission accomplished. We now know that there are about 1,000 near-Earth objects that are larger than 1 kilometer, and we have found at least 900 of them. So we've accomplished that part of the mission. But in terms of finding those 140 or larger near-Earth objects, that by the year 2020, we're not even close. We won't make that goal even close. And the reason is the process of finding these small guys is actually very hard, and there are very few resources involved in doing it. In the last 12 years or so, nearly all near-Earth object discoveries have been done by these 3 telescopes. These are at the Catalina Sky Survey on Mount Lemmon near Tucson, Arizona. And these are big telescopes on a high mountain peak, and they have been scanning the skies for quite a while. And most of the discoveries have been credited to the Catalina Sky Survey. A couple of years ago, another telescope joined them. This is Pan-STARRS 1. This is in Hawaii. It's also a big telescope capable of scanning quite a bit of sky at one time. And together, these are the guys that do 90%, more than 90% of all the NEO discoveries. And what they do is they scan the sky each night, but they don't scan the entire sky. They can't do that. What they can do is only scan portions of the sky each night. So this is a graphic showing the parts of the sky that were scanned during a 5-day period by all of these telescopes. Now, as they scan the sky, they only look at each part of the sky for a short period of time. If they spot something moving, they make an initial effort to identify it. If it can't be identified, then they report it to the Minor Planet Center. The Minor Planet Center is run by the International Astronomical Union, and it is the global clearinghouse for all asteroid data. If one of the survey telescopes reports an object to the Minor Planet Center and says, we can't identify this, the Minor Planet Center will do some calculations about it and then post the data on their website, inviting other observatories to try to confirm this possible discovery. The other observatories are not big telescopes like the ones on Mount Lemmon. They're mostly much smaller telescopes. University telescopes, smaller research telescopes, and even amateur telescopes. So up at the Chabot Space and Science Center, we have a 36-inch reflecting telescope. We're part of that network that confirms or follows up on the discoveries made by the survey telescopes. But a lot of this work, there's a network of about 350 observatories around the world, and a lot of them are amateur telescopes. This is an example right here. This is a guy in England. His name is Pete Birtwistle. And Pete has a small 2-meter diameter dome in his backyard. And in England they call it the garden, but we'll call it the backyard. He has a 16-inch telescope. And this guy spends a tremendous amount of time searching the skies, trying to confirm or follow up on these asteroids that may have been discovered by the survey telescopes. In fact, he does it so much, he's so prolific, and he has a daytime job. You wonder, when does a guy sleep? I heard an interview once with Pete Birtwistle, and he said he was an airline pilot, so I guess that explains it. Okay, how do we do it? How do we find these things? The process is pretty straightforward. We take 3 or 4 images of the same patch of sky, and then we just look for a moving dot. The word asteroid means star-like. So what we're looking for is a star-like object that moves in each of these images. So you all look at this and you can all tell where the asteroid is, right? Maybe not. So what we have to do is do some processing. We scale the images using known stars. We identify the known stars in the images. We scale the images based on the coordinates of those stars. And that allows us to put all the images together, align them properly, and we develop an equation that gives us the corresponding stellar coordinates that relate to the pixel coordinates. Once we do that, it's a real simple process to find it. All we got to do is blink through all the images. And you see the asteroid there, right? You all knew where that was, right? Okay, so we found our asteroid. Now we need to get some data on it. We use specialized software to extract data from these images. These images are not in JPEG format or TIFF format or anything like that. They're in a specialized format that we use for astronomy. And we use this special software to extract data. We get 3 pieces of data, the exact time, down to a fraction of a second of that image, the astrometric position, which is the coordinate system that we use on the star charts and so on, and the photometric magnitude, which is the brightness of the asteroid. Again, they just look like stars, like little dots on the screen. So brightness is something we use to try to estimate the size. And that can be a challenge because all you're looking at is a dot, and just because it's bright doesn't mean it's big. On the other hand, if it's dim, it could be very big. An asteroid that's very dark in color, like this one here, might show up at the same brightness